Hello, everyone. I would like to welcome you to today's SWANA e-learning event. My name is Shelby Truxon. I am filling in for Jesse Maxwell. Right now, you should be seeing a slide on your screen that has the title of today's webinar and a list of our upcoming events. Okay, so before we begin, I would like to explain some of the features of our webinar platform. So first, you can download today's presentation slides by selecting the file on the right-hand side of your screen and then pressing the Download Files button. And to send a message during the presentation or during our question and answer portion, please use the chat box, which is also on the right-hand side. And the participants box shows you who is on today's call. So welcome to everyone. We have about 24 people, which is awesome. And then after the presentation, there will be a time for question and answer. So you can type those in as we go along, and our speakers will answer your questions. This is just pointing out where everything is for you again. Okay, so now we're switching over. Speakers for today are Olivia Williams and Rich Hansen. And just briefly, Olivia Williams is an environmental engineer at HDR in Seattle, Washington. She has a technical background in solid waste facility design, including landfills and transfer stations, as well as experience in site investigations and remediation. So after graduating from Ohio State University, Olivia first worked in the Midwest before relocating to Seattle, where she focuses on working across Washington and Oregon. And then Richard Hansen is a senior engineer with the City of Spokane. He received a degree in civil engineering from San Diego State University. Mr. Hansen is a professional engineer and member of SWANA, and he has worked in the city's solid waste management department for 6 years and manages the city's 2 closed and 1 open landfill. So with that being said, I would like to turn things over to our speakers today, Olivia and Rich.
Thank you, Shelby, and thank you to SWANA for having us here today to share our presentation with you. Thanks to all the participants for joining us here today. Rich and I are going to be presenting to you on 7 steps to simplify landfill gas management at a closed landfill. So what we are going to be doing is walking you through what we call a step-by-step approach, which is just a fun way of kind of sharing a case study with you on the Spokane Southside landfill, which is a closed landfill site in eastern Washington. So the steps that we're going to take you through today here, Rich is going to give you a bit of a background on the site itself and a project introduction. Then we'll take you through the 7 steps that you can see here on the screen. We started out with an overall audit, then get into some of the details of a landfill gas assessment and the landfill gas monitoring. We'll take you through the permitting and design process and then tell you about the upcoming construction and the follow-up monitoring. And then at the end, we'll spend a few minutes and talk with you about the project as a whole and some of the benefits that we feel that it provides. So please feel free to write in the chat box if you have questions. I think Shelby will bug you at the end to see if you can help facilitate some of those for us, and we'll be happy to get those answered. So with that, Rich, I will kick it over to you.
Thanks, Olivia, and good morning or good afternoon, depending on where you're at. And welcome to our webinar this morning. Just a little background about myself. I've got about 22 years in municipal engineering with various different municipalities. I moved into landfill management, as Shelby said, about 6 years ago, a little bit more than 6 years ago now, and spent the first 2 years trying to determine, based on reading reports or different documents, what needed to be done at the landfills. The last person ahead of me that was in the management position just kind of left and left a lot of untied string, on loose ends, basically. So after realizing that the approach, the piecemeal approach, wasn't working, utilized SWANA for some training and got into the industry that way and started to understand it outside of the small area of Spokane up here. And while doing that, I attended a SWANA conference and was taking a landfill gas training there. Ran into an instructor named Dick Prosser, who I was trying to brainstorm ways of addressing this issue, that I had an old landfill that needed some attention, how to determine what attention was appropriate, how much that attention would cost, those type of things. And he suggested that we would do a site-specific audit of the systems and the overall condition of the landfill. So with that in my pocket, I came back to Spokane and talked to my supervisors, and we began the process of hiring HDR engineers to perform the audit. As this slide says, this is a kind of a shot of our south side landfill. We have two landfills, north side, which encompasses a 175-acre closed portion and a 25-acre open portion there that's used to support a waste-to-energy facility that's in the region. But those two are about 40 minutes driving time apart from each other. So we spend the majority of our time at the north side and come down here as we need to. This started out as a regional dump back in the early 1900s, and it was acquired by the city of Spokane in 1968. After operating it as a sanitary landfill until 1987, the city ceased operations and ceased accepting waste at this site. And in 1988, a gas collection system, an engineered cover system, and an enclosed flare was constructed. Oh, I'm trying to change the slide here.
Bottom left.
Bottom left. There we go. Thank you so much. All right. This is an overall an aerial view of the location. Down there, you see the yellow portion is the boundary of the project. For about 2/3 of the site, we have single-family residential around the outside of the boundary here. Towards the upper right-hand side, you'll see a red roof there. That's an elementary school that's in the local area as well. This site is actually outside of the city of Spokane boundary, but the city still does maintain the liability for it. It's an unlined landfill, which is, I think, very common for landfills that began way back in the early 1900s. And we utilize, you see a treat area on the upper portion of the boundary. We fence that off and use that as a walking area for the community. It's heavily used. It does have gas monitoring perimeter wells up there that are actively monitored, but the people do a good job of helping us to make sure that those things don't get vandalized in that area. The terrain slopes from the upper portion of the way that the picture shown there to the lower portion. And as you get down to where the words project site are, it gets very steep on that end. And so it steeps down into a ditch that's way down back there. The groundwater flows from the upper right to the lower left, as the picture shows as well. Some of the issues that I was trying to evaluate piecemeal-wise and what caused us to get into the audit included areas where we had increased settlement or large settlement areas that were causing flooded conditions in heavy rain and early spring with snow melt-off around some of the gas collection or gas monitoring points. And in addition, were causing excessive loads onto the cover itself. The cover that was engineered and placed on here wasn't the type of cover that I see in other places where it's completely welded. This was kind of a slip cover that was supposed to account for the settlement, so they were overlapping, and as the settlement would occur, the membrane would slip across itself to continue that covering. So there's the thought that if we have this ponding occurring there in those locations, that we could get some surface water intrusion into the landfill. We don't have anything to substantiate that, but it's a possibility that exists out there. Segs in the gas collection lines have produced blockage from condensate buildup at certain times of the year as well. That has caused the flare to shut down more often when we have heavy condensate being produced in the system. In addition, at the flare, we have a carbon monoxide problem. It's not out in the field. We've tested the gas, so we don't have a landfill fire type situation or anything that is being produced out in the field. It most likely comes from incomplete combustion at the flare itself, and we've worked with John Zink, who's the manufacturer, to try to rectify that condition in response to our regional clean air agency requiring us to do something about that. We continue to gather carbon monoxide data from the flare, but we have not found any way to correct that situation yet. And besides those issues, we just have an old almost 30-year-old landfill. The gas quality and quantity are on the decline. The flare operates at most 5 days out of the week, but sometimes only 3 days. And so we have to go up and manually restart that flare a number of times a week sometimes. And we're required to get 3 to 5 carbon monoxide readings a week, so we can only do that while the flare is operating. And then in addition, it's almost 30 years, and the old school thought was that 30 years was just about it as far as where things would be in an old landfill for having to monitor and operate it. Now, as we get closer to that 30 years, we start to see that that's not necessarily possibly the right solution. So we're starting to work with ways to show our regulators that we're operating in good faith and that we want to try to find some reasonable way to plan out the end of landfill life issues that are coming up for us and for so many others. So back to the audit, we hired HDR engineers, and they proposed a systematic approach to help us to identify and evaluate the issues. We have 2 technicians that have been with us for a combined 25 years, so that's a lot of experience about handling, operating, maintaining these landfills. And so HDR came in, gathered data, just raw data, and then also interviewed the technicians to find out some other issues that were ongoing from their point of view. And HDR put that together, and Olivia will speak more to this as we go along. But they put together a way for us to identify items that were in need of immediate repair, some things that could be put off for a few months, and then other things that were more long-term repair. They helped us to evaluate if those repairs could be done in-house or if we needed to bring a contractor in, and then put together preliminary budget ranges for each of those so that we could start to identify a budget item to do these repairs as we went along. HDR, along the process, came to us and said, hey, we think that you ought to consider going to a biofilter here. It'll remove things like your carbon monoxide issue of having to operate the flare. It'll eliminate a lot of the weekly operation issues and reduce your annual operating costs. Those were all things that were very attractive for us to hear. And so we're very excited to do that. We went and did an addendum to the consultant contract, and they began to do that, and that's what brings us up to today. So with that, I'm going to turn it back over to Olivia, who I'd just like to say I've had the great fortune of working with on this project since its inception, and so I'm just very thankful that I get to do this with you, Olivia. There you go.
Oh, thank you. It's been great, and we'll keep it going. So to provide a little bit more detail on the audit that Rich described, we joined the project in 2010, and what we're going to walk you through today is really sort of an overall 2-part project. Part 1 was the audit that Rich described, and then as we started honing in on some of these landfill gas issues, we really focused on that biofilter piece, which is the second part of the process. So as Rich mentioned, step 1 that we recommend in working at an older landfill site like this, especially when you have changeovers in staff and some institutional knowledge that can be lost along the way, what we recommend is really doing kind of a snapshot audit that really gives you a good idea of what the existing conditions of the site are. And so as Rich mentioned, That involves looking at the actual site itself, collecting data, but also really hearing from the operators because they are a critical piece of how that site has been maintained over the past number of years. And a lot of the anecdotal stories that you will hear, the data collection, the tweaks to operations and things like that, those can't be observed out in the field. So that's a really critical piece of the audit process. So what we discovered as we were going through and conducting this audit is that there, as Rich hinted at, there were probably ways that we could look at to streamline landfill gas operations. And so of all the recommendations that we made as a result of the audit, the landfill gas pieces are really the ones that we honed in on. Before we start to focus on those, though, I just wanted to give you an idea of what the results of that audit process looked like, because again, that's really kind of the first piece in evaluating your site conditions. Rich described some of the issues that had been observed at the site with the stormwater ponding and things like that. So we wanted to make sure that we had a good baseline documentation to work from so that we could come back to that at any point during this project and really recall what the challenges and what the issues observed were. And so those observations, the audit really focused on 4 major categories of the site conditions. And those are listed here. It's the cover, it's the surface water management system, it's the landfill gas collection system, and then the flare station itself. And what you can see on the screen here along the bottom are some selected photos from our audit that showcase some of the issues identified during our site walk. On the left-hand side, you can see 2 photos of the landfill gas collection wells and trenches that are interior to the landfill itself. The valve boxes, due to the settlement of the site, had collapsed over time, and it made monitoring rather challenging. The third photo over from the left is a stormwater berm with some localized settlement and some berm washout occurring. And then the furthest photo over on the right is an example of some of the steep slopes that Rich talked about on the south side of the site. There's surface water overflow happening and washing out part of that road. So in addition to the landfill gas that we'll focus on today, there were a number of other challenges that were observed and recommendations were made for addressing those. So after that initial piece, as I mentioned, we really started to focus on the landfill gas elements in particular because that's where we saw a lot of room for improvements. And as Rich noted, a lot of opportunities for potential savings based on how the existing facility was being operated. So the existing flare is an enclosed flare, and it typically operates between about 450 and 550 cubic feet per minute. But as Rich noted, based on the age of the landfill and the declining quality of the landfill gas, that was becoming a very intermittent operation. So it was only operating between 3 and 5 days per week. The low methane would cause the system to shut down, and then one of the operators would have to come from the other landfill site to check on that, to restart it, and to collect that monitoring data that Rich described. So in addition to the carbon monoxide that was observed as an issue at the flare, the landfill gas system, including the flare, was being monitored for kind of your standard landfill gas parameters. So those included methane, carbon dioxide, oxygen, your balanced gases, and then the overall landfill gas flow and the landfill gas temperature, so that you could keep an idea of the overall condition of the landfill itself as it continues to age. And what we've shown in the bottom corner here is just a summary of the historical readings that are collected on a monthly basis. We've wrapped those up into an average over a 5-year monitoring period here. So you can see specifically for methane at a concentration of just under 25%. That's pretty low for landfill gas generation and for continuous flare operation. So you can see how some of the challenges that the city was encountering could be happening. So once we focused in on the landfill gas piece, we decided that we needed a bit more data on the existing conditions of the landfill gas in order to determine the best solution. So in 2011, we conducted some additional landfill gas sampling, and we worked with the staff at the city to help us collect those efficiently. And we conducted sampling for toxic air pollutants, or TAPs, and those are collected using a SUMA canister and a laboratory analyses, EPA TO15. So that monitors a lot of your standard air pollutants that would be an issue or a concern for the Clean Air Agency. Additionally, because hydrogen sulfide, or H2S, is a common odor contributing factor to landfill gas, we also conducted H2S sampling over about a 2-week period at the flare itself, and that was done just using a handheld LandGem monitor like you typically use for site landfill gas monitoring. So we observed H2S concentrations between 2 and 5 parts per million. So we conducted this background data in order to give us, as I mentioned, a baseline for how best to move forward with a potential landfill gas biofilter design. So in order to get to the permitting stage, we knew that we'd need to do some landfill gas modeling with the data that we had collected. So we conducted some landfill gas modeling, and we compared those to the state of Washington air requirements. And so in the state of Washington, there's sort of a 2-stage threshold for air quality emission rates. And so those 2 stages are noted here. The SQER, those are your small quantity emission rates, and that's sort of a snapshot benchmark. If your anticipated emissions are less than your SQERs, then you're good to go. However, if you are higher than the SQERs, you can do some additional modeling to determine if the ASILs, or your acceptable source impact levels, will be exceeded. And if you can show that your ASILs will be met, then you are typically able to move forward with the project. However, if your ASILs are exceeded, that's when you need to go back and you need to think about some additional air pollution controls that would help get you under those regulatory thresholds. So based on the results of the landfill gas sampling that I described in 2011, we identified 2 key parameters that would be an issue for tracking and for permitting with respect to converting the flare to a biofilter. And those 2 major issues, or those 2 major parameters, were vinyl chloride, because that came back over the SQER levels, that initial threshold that I mentioned, based on the TO15 sampling, and then hydrogen sulfide that we monitored in the field. You can see here that the SQER amount, the initial threshold for vinyl chloride, is 2.46 pounds per your average period. And that period changes per parameter, but it's typically about a year. Now, our estimated emissions from the landfill gas biofilter were 22.6 pounds, so nearly 10 times the initial threshold. So we knew we'd have to do some additional modeling. So what we did was we came up with a preliminary design for the biofilter, including a stack for the release of the treated gas, and then we ran it through the air quality model for the specific location at the site, including the specific atmospheric conditions, and we came up with results of 0.0114, which is highlighted on the bottom here in yellow, for vinyl chloride, meaning that in this exact condition, in this exact location, with the stack that was designed, we would be below the regulatory threshold, which would allow us to move forward with this project. Now, we also monitored hydrogen sulfide, as I mentioned, as a potential odor concern. The estimated emissions for the biofilter were actually below that SQER, that initial threshold, so we didn't need to do any additional monitoring for that parameter. However, because odors we knew would be a primary concern for the regulatory agency and for potential neighbors to the site, we did go ahead and run the model using hydrogen sulfide as well, so that we could figure out if there would be any impacts, and if so, where those would be. So the next couple of slides here show a graphical representation of the air quality model that we used. The one that you see on the screen here shows concentration contours for your vinyl chloride. So you can see the star towards the bottom of the screen. That's the proposed biofilter location at the northern property of the landfill. Now the area in pink and then the area again in green, those are your highest concentrations anticipated for vinyl chloride. So as one might expect, the highest concentration was pretty close to the biofilter, and it's in that area that Rich noted that is owned by the city of Spokane but is used for public trails and walking. However, because the concentration for vinyl chloride is now well under that ASIL threshold, we felt comfortable making the recommendation that this was an appropriate technology to use and that there would not be any adverse impacts based on modeling the vinyl chloride. Now, as I mentioned, we also wanted to consider odor when we were modeling this technology as well. And typically, odor detection for kind of an average human being, minimum odor thresholds for being able to detect an odor are between 5 to 10 parts per billion, or what are called odor units. Now, when we conducted the landfill gas modeling, as I mentioned, for hydrogen sulfide, you can see the results here. The highest concentrations are anticipated right around the biofilter. Again, they're shown in green. And also kind of an interesting spot off to the northeast, and that's just based on, again, the climate data and the topography in the area. But you can see the peak odor units anticipated based on our modeling were at 1.74, which is below the 5 to 10 range that's typical for normal detection. So again, we felt comfortable that this was an appropriate technology based on those key parameters that we'd identified. And we felt that this modeling and the data that we collected really told a good story to the Clean Air Agency, that we were able to mitigate any potential air quality impacts by utilizing this biofilter technology. So that got us through a major step in the design process. And moving on to the next piece, again, we were evaluating landfill gas collection and flaring as a whole comprehensive system. So we talked about the flaring piece. Now we wanted to take a closer look at how the site was monitored by the city. So the existing landfill gas collection system at the Southside Landfill includes a series of internal wells and trenches for collection. That's piped to a landfill gas blower and then to the flare. And then additionally, for monitoring, there are a series of 68 landfill gas probes, primarily on the north side of the site. And those are grouped in collections or clusters of wells that are monitored at different depths so that you can see any landfill gas impacts in the different soil strata outside the landfill. Additionally, a number of years ago, the city had a potential concern for some off-site migration of landfill gas, primarily on the northeast part of the landfill. So 22 extraction wells or vacuum wells were installed along the northern boundary of the landfill, outside the waste, but they essentially created a cutoff trench to collect any landfill gas before it migrated off-site. That system operated for a while, and then when it was determined that it was no longer necessary, those extraction wells were shut down. But the city continued to monitor those just to make sure that they were doing their due diligence and observing any potential issues before they arose. So you can see on this next slide here, this is a site map that shows the landfill gas collection and monitoring system. The yellow line work, that's the collection trenches and the wells that I noted. The yellow circles on the north and eastern boundary there, those are the 22 extraction wells that I mentioned that were still being monitored. And then the green triangles on the, again, primarily the northern side, those are the clusters of gas probes that were being monitored. And this was happening on a monthly basis. So this was quite an effort for the landfill staff to go out and collect this data regularly, especially, as Rich noted, with folks coming from the north landfill site, to do this on a monthly basis was no small feat for the landfill operators. So what we did is we worked with the city to go back and we reviewed the permit conditions. And the permit conditions actually noted that the monitoring needed to be conducted no less than quarterly. So as the previous landfill gas issue arose with the potential migration, the city had stepped up their monitoring and were doing that on a monthly basis. But after that issue was mitigated, the frequency was never reduced. So in reviewing the permit, we went back and noted the quarterly monitoring requirement, and we made the recommendation to the city essentially to reduce their frequency from monthly to quarterly. So you're going back from 12 monitoring events per year to 4, which could significantly reduce the amount of labor associated with your landfill gas monitoring requirements. Additionally, we made the recommendation to the city to no longer monitor the perimeter extraction wells. The previous potential issue with landfill gas migration had been addressed. And when you went back to review the permit conditions, they then referred the reader to the closure plan and said that the monitoring locations required were as per the 1988 closure plan. So sure enough, in going back to review that closure plan, it specifically calls out the landfill gas probes as the required monitoring locations. So we recommended to the city to stop monitoring the 22 extraction well locations. Again, it was a good idea in doing the city's due diligence when that potential migration issue was occurring, but after that was mitigated, there was no real driver to go back and monitor those wells anymore, especially considering that was not their, that monitoring was not their additional purpose. So, though the combination of those two significantly reduces the amount of operator labor required to monitor the landfill and the landfill gas system each year. So we've provided notification letters to the Clean Air Agency. Again, because we were in compliance with permit conditions, we didn't ask permission, but we provided notification that the monitoring conditions at the site would be changing. So the next step was the permitting process. And in the state of Washington, the local Clean Air Agency requires what's called a Notice of Construction, or an NOC. That's essentially the permit for any new air pollution control equipment. So similar to an industrial baghouse or to a scrubber, installing the flare, or now this proposed biofilter, is considered air pollution control equipment. So we needed to go through this permitting process to get approval to construct the biofilter. Now, we walked through the technical process behind the biofilter with the Clean Air Agency, and fortunately, it was a process that they were familiar with because they had actually permitted a similar project in eastern Washington a couple of years before. So this one that we're working on for Spokane is the second one in the state. The general thought, or the general technical process behind the biofilter, is that it's oxidation of landfill gas instead of thermal destruction of landfill gas, like the flare currently does. So the combination of the methane, the oxygen, and then the nutrients that's in the biofilter material breaks down the landfill gas into harmless constituents. So you get what's called a biomass, which is your biological result of the bacterial process, and then you break it down into carbon dioxide and water. So it's a fairly straightforward chemical process. So the Clean Air Agency was comfortable with the technology and the logic behind the biofilter itself. So we went through and presented a Notice of Construction permit package. That included the previous landfill gas data that was collected, as well as the modeling results that we did. It also included a SEPA checklist, which is the State Environmental Policy Act. That's required for most any new construction project, and it looks at impacts on aesthetics, impacts on noise, impacts on traffic, etc. But because we were working at a closed landfill that had been here a number of years, there really were virtually no additional impacts by converting the flare to the biofilter. And then the last piece of this Notice of Construction application was the preliminary design. So what we submitted was really a rough schematic at that stage. The 450 to 550 CFM that I mentioned at the beginning of our presentation was assumed to be prorated out to continuous operation. So if you're at 400 to 550 CFM 3 to 5 days per week, if you spread that out and assume continuous operation, that gets you down to about 221 cubic feet per minute for continuous operation. And the thought process was that we would utilize the existing landfill gas blower that keeps a vacuum on the landfill itself, but instead of venting it through the flare, we'd vent it through these new biofilter units. The original vision was that we would have 4 modular biofilter units operating in parallel. That way, if you needed to replace the media in one, you could have one down while you're operating the other. But you still get the appropriate surface area needed to provide the biological treatment of the landfill gas. And then those 4 biofilter units would have the treated gas collected, and then they would exhaust to a stack, as I mentioned, for purposes of the landfill gas distribution. Inside those biofilter units, as shown here kind of in a green color, we proposed a biofilter media that would be about a 50-50 wood chip and green waste organic mix that would have some sand mixed in as well to get the porosity that you needed. As you can see, the general intent here, the landfill gas from the landfill itself through the blower would come into the bottom of these landfill gas units, and it would be percolated up through the media for treatment. At the top of the biofilter units, then you can see the callouts for some water sprayers, and those are intended to keep the biofilter media moist, because that's how you really optimize the bacterial generation that breaks down that landfill gas. Then from the top of those enclosures, as I mentioned, the landfill gas would be collected and treated. So these units, as we were thinking through them, would be on the order of about 20 feet long, about 5 feet tall, and as I mentioned, we were thinking there would initially be 4 of them. The piece that we struggled with a bit was the actual implementation and what these would look like. As you can see on our drawing here, one of the call-outs we have is that this would be some sort of roofed structure or tarped structure. But we were trying to figure out, would these be actual box enclosures? Would they be something that was constructed in the field? We had to go back and do a little bit more thinking about what the actual design looked like. So once we made it through the notice of construction process, we got approval from the Clean Air Agency to move forward with this project, and we started to delve into some of the design details. So as we called around and spoke with some different vendors about potential modular units, we discovered that there are a couple of vendors that use roll-off boxes that are typically used, for solid waste, recyclable collection and hauling, that have converted those into modular biofilter units. So in looking at the sizes available of those, we optimized the 4 biofilter units that we initially proposed down to 2 units, and those were 2 27-yard roll-off bins. So we were able to provide the same depth of media, and we were able to provide the same surface area required for treatment, and the target parameter there that we were looking at was what's called the residence time. That's how much contact time the landfill gas has with the biofilter media itself to allow the bacteria to break down the constituents in the gas. So we were able to convert and streamline 4 units down to 2, which saved on the overall material pricing for construction as well as the overall footprint of the anticipated biofilter unit. The media itself we anticipated, as I mentioned, to be wood chips and green waste, and that's something that because the city operates solid waste operations throughout the city, that's something that would be readily available to the city. So that was a nice opportunity to be able to utilize existing materials. One of the question marks that we still have, because as noted on this slide, we've made it through the design process, but this has not yet been constructed. So one of the question marks that we have is how often the biofilter media will need to be changed out. Whenever you run gas or media like this, you hit a point called saturation, and that's essentially where your media can't process any more gas or any more water. You've made it through that point where your treatment is effective and it no longer has moisture content of the media is in 40 to 60% range. That's kind of your optimal range where you'll get that maximized bacterial growth. So we're able to control the sprayers to provide that optimal moisture content by monitoring the media. And then the biofilter effectiveness. This was something that was really critical to getting the biofilter unit permitted. Based on the parameters and the concentrations in the existing landfill gas, we expect that the efficiency of the breakdown of the VOCs, the volatile organic compounds, in the landfill gas itself is between the 50 to 90% range. And that gets us below those regulatory thresholds that we discussed earlier. As a backup, though, we do need to maintain the flare, and that was an interesting point that came from the regulatory agency. If for some reason this biofilter is not effective or we end up having any downtime for some reason, the landfill flare will remain as a backup. So everything can be valved and the landfill gas can be sent back over to the flare if need be to operate temporarily while we get the biofilter back in line. So the flare will remain in place, it won't be removed, but it will only be there as a backup. So I'm seeing a couple comments here about how the sound went away. Hopefully it's back now. If there are questions on any of this stuff as we get to the end of the presentation, please don't hesitate to ask if there's anything in particular that we may have covered during that period. So to help you get a visual, I've attached a couple of pictures here in step 5 that show what these typical biofilter units might look like. Now these aren't the ones that are actually going to be used at the Southside landfill site, but one of the vendors that we worked with provided an example like this of ones that they've used. So we are assuming that it's an enclosed biofilter. You can see there's a tarp system across the top. It's important to note that it's not a airtight and watertight system, so these biofilters will need to be located on a concrete pad to collect any leachate or drainage that does escape the biofilter unit. But this does do a good job of trapping the majority of the landfill gas that's through the media and then routes that to the collection points that we'll see on the next slide here. We hope that this is a pretty straightforward way for the city to maintain the biofilters. As you can see, there's some ratchet straps on the side of the unit here. So those are pretty easy to release the cover tarping system. And there's a winch so that you can roll that tarp back. On the right hand, a bit tough to see, but on the right hand side, you can see that there is a door that swings open. So if need be, you can check the status of the media there. You can use that as an access point if you need to swap out material, etc. So there's a couple good access points, and the idea of these biofilter units are that they're pretty easy to swap in and out. So this gives you a little bit more detail here about what's contained inside that biofilter unit. What you're looking at here on the top is essentially a plan view. So if you were looking above the biofilter unit down inside, and then the bottom is a section or a side view so that you can see the different layers inside the biofilter. So across the top, we talked about the water sprayers earlier. So what you see as the vertical lines kind of spaced across the top of the biofilter unit are a series of perforated pipes. So those are assumed to be spread about 4 feet across or centered about 4 feet across and then evenly distribute water throughout the media from the top down. Now if you look at the bottom view, you'll see a long perforated pipe running from side to side. That's where your landfill gas comes into the biofilter unit. It percolates up through a geocomposite or like a geonet with a membrane or a textile on top. And that just prevents your wood chip mix from settling down and blocking any of your perforations in the landfill gas. So it keeps the piping separate from the media and allows for good gas flow up through the bottom of the biofilter unit. We'll talk about it a little bit more on the next slide here, but you can see a couple of piping connections. The piping connections on the bottom here, as I mentioned, are where gas comes into the landfill or to the biofilter. There's also a drain pipe on the bottom, so as any water that percolates down through the media makes it through that geocomposite and collects on the bottom of the biofilter unit, that is collected and then routed to a existing condensate sump that was previously essentially a knockout tank for the floor. So any of that water that's considered leachate is collected and disposed of. And then at the top of the biofilter unit, what's shown on the top left of that bottom view, that's where your landfill gas is collected, and then it's all routed from the 2 units to a central stack. So again, I'm seeing we're still having issues with the sound. I apologize. If there's any questions about the specifics of the design, please note those, and then we'll get to them at the end. This color-coded view of that same graphic kind of shows a couple of the different piping systems. We originally gave this presentation about a month ago at the SWANA conference down in New Orleans, and there were a couple of questions about how the media would be changed out. So we added this slide to provide a little bit more information. We kind of joke around and call the media change-out process a plug-and-play. We've made this as easy as we can for the landfill operators to be able to swap out the biofilter units. So because they're modular, what we expect is that the piping manifold that's shown in blue on the top view here, that's your water sprayers. We would expect that when that media is saturated, that tarp can be rolled back, and that top manifold, the water sprayer manifold, can simply be picked up. It's a 2-inch perforated pipe series, so it's not very heavy. It could be picked up with a small piece of equipment and set aside. The same thing could happen with the piping shown in yellow. That's your landfill gas piping. All of the piping that is connected to the biofilter unit, we're anticipating will be done so with a cam lock or similar fitting. That cam lock fitting is shown on the bottom left. You essentially attach it and fold down the locks, and so it's really easy to pop this on and off. The piping is not hard piped at that location, so it would be connected with flexible hoses. That way you're able to unplug your piping, pull the whole biofilter unit out itself, and swap it back in with a spare that's already pre-filled with that biofilter media, and then you can roll that tarp back over on top, plug your piping back in, and you're ready to go. So your downtime is very minimal when you're swapping out the media. That was one of the challenges that we looked at in doing this design. We wanted to make sure that it would be fairly straightforward and that the landfill staff wouldn't be out there with a skid steer and the biofilter would be down for a few days or for a week. We've made this as quick and easy as possible, and we think this plug-and-play idea will really work well. So we've talked a lot about the biofilter unit itself. I wanted to give you a bit of an idea of how that fits into the context of the existing site. It may be tough to see up here, but this is an aerial of where the current flare and blower is located at the landfill. What's shown in the black line work here is all of the landfill gas collection piping coming into that flare station. And then the colored diagram down here is how the new biofilter will tie into that existing infrastructure. So we've got an existing blower up here shown in the gray, and then there will be new landfill gas piping that's shown in yellow that will bring the landfill gas from the landfill through the blower and push it out through the two biofilter units that are shown in green. So as I mentioned, this connections to the actual biofilter would be done with flexible hoses so that it's very easy to swap in and out. Once the gas is treated, then the landfill gas is collected out the top of both of those units and then routed over here on the left-hand side or to the west where it is discharged using a 4-inch stainless steel stack. Now there are existing infrastructure at the landfill that provides a potable water source. So there's a trailer adjacent to the landfill gas flare station where we can tap in to bring water in for the sprayers. So that's what's shown on the left-hand side here in blue. That water, again, can be valved and plugged into the biofilter units so that it's sprayed down through the media. And then on the right-hand side here, that water can be collected and sent over to the existing condensate tank that was already there for the flare. So while the piping diagram may look a bit confusing, it's actually fairly straightforward as far as kind of landfill gas in, landfill gas out, water in, water out. And the sources and discharge locations for both of those are based on existing infrastructure. So again, we've made it utilize the existing resources to the extent that we can. So as I mentioned, task 5 or the design phase is where we currently are in this overall project. So the next step would be to construct this biofilter system, and that is anticipated for sometime this calendar year. Because the units are modular and the city has already gone ahead and procured the actual biofilter roll-off boxes themselves through an existing contract, we anticipate that construction for this would be fairly straightforward and could be done in about a 2-week time frame. So we've put together our engineer's cost estimate for the various pieces of the project here, and we anticipate that the capital cost for installation of the biofilter is on the order of about $84,000. So the final step, once the biofilter is constructed, is to do the follow-up monitoring. And this is important so that we as designers have a good understanding of how the facility will operate. It's also important to the city and to the Clean Air Agency to make sure that this biofilter technology is appropriate for the application. As Rich mentioned at the beginning of our webinar here today, the site is nearing the end of its post-closure period, and so we would like to do what we can to help the city minimize and optimize the operations required on site to eventually be able to prepare the justification to exit the post-closure period. So within 30 days of startup of the system, the Clean Air Agency has required that we prepare an operations and maintenance plan. And as with many projects, but especially ones associated with landfill gas where the anticipated results are not as predictable as you'd always like, it'll be very helpful to have this 30-day period to be able to work through some of the tweaks and some of the startup challenges that may occur in putting in this new technology. So that O&M plan will require that the city does regular monitoring of the biofilter system for the temperature, the moisture, the pH, and the pressure drop across the biofilter. As I mentioned, the temperature and the moisture are key parameters in making sure that the biofilter is operating under that optimal condition where your bacteria are really breaking down the landfill gas. The pressure drop across the biofilter helps to note if there's any clogging or will help track that saturation period that we talked about earlier. So as you note that your pressure is increasing, you're getting to that point where your landfill gas treatment is not effective. The Clean Air Agency would also like to be notified at least 2 days in advance of replacing the biofilter media. I think the way that we've approached this, as I mentioned, kind of plug-and-play operation has piqued their interest, and they'd like to see how that will work. So that is one of the monitoring and maintenance requirements for the biofilter moving forward. And then additionally, the Clean Air Agency is going to require that the city samples and reports the toxic air pollutant concentrations at least once per year. Now, as Rich mentioned earlier, they're going out and doing regular sampling right now, or regular monitoring for carbon monoxide and for a number of other parameters. So doing this once per year will really reduce the amount of operating labor required for monitoring the landfill gas system. And then lastly, as I mentioned, the flare is required to be maintained in case of any sort of upset to the biofilter system. So those 4 requirements bulleted there, those were the requirements on the city as part of the permit process for the biofilter moving forward. Now, after we gave this initial presentation at the SWANA conference last month, I had a number of folks come up to me afterwards that said that they had recently, in the past couple of years, worked on similar projects at different landfill sites across the country. And they noted some of the challenges that they experienced in the startup and testing and the implementation of the biofilter. So I've noted those here because I thought that those were interesting and will definitely be ones that Rich and I need to watch as we get this system underway. First off was the odor. Like any bacterial colony, it takes a little while for the bacteria to become established. And so in that initial startup and testing phase, some folks explained that they had experienced higher odors than anticipated while that bacterial growth really got underway before it was truly effective in breaking down the landfill gas constituents. So that was helpful to note in that we may experience some higher odors initially before that really gets well established. It'll also be very important for us to monitor the optimized operating conditions, as I mentioned, particularly the temperature and the moisture. To go along with the previous bullet there, those will really help to establish the bacterial colonies that are effective in breaking down the landfill gas. And then the last piece that will be a challenge, as I noted, is really figuring out the best timing and implementation for changing out that media. Because we haven't done this before, this will be an interesting thing for us to try and to see how effective it is. And if there are challenges associated with the approach that we've identified, the great thing is that the city has a very strong technical understanding of how the landfill gas process works and how this biofilter process works. So if they need to make adjustments in how that's done, they're very comfortable and very competent in doing so. We joked around a bit at the SWANA conference about a potential step 8 in this presentation too. Someone asked about carbon credits, and that's not something that we had considered thus far as part of the project. We were really focused on the permitting and the implementation. But going back and looking at the carbon credits associated with not flaring the landfill gas is something that could really provide value to the city of Spokane at a higher citywide basis. So that may be something that we look into once we get this biofilter well established. So in closing, we have some final thoughts for you about this particular assessment and technology and how it might apply to different sites around the country. Based on the anticipated labor reductions that we foresee as part of this project, we talked about reducing the monitoring frequency as well as reducing the monitoring locations. And then additionally, we anticipate benefits in not having to have a landfill operator come out to the site each week to do the CO testing and to restart the flare. We anticipate there being about a $24,000 per year savings in labor by installing the biofilter and not having to monitor and maintain the flare. Based on the anticipated construction cost, this would mean a payback period within about 4 years, which is not too bad. That really helps strengthen the argument when you're talking to management, to regulators, about the benefits of this project. And again, it's a lower maintenance operation, which will help them take one more step closer to exiting that post-closure period eventually. And here's some kind of overall summary thoughts that we had, again, as I mentioned, in application potentially to other locations. Similar to a lot of other closed landfills, closed doesn't mean forgotten. With closed landfills, especially ones that are a little further away than an urban core, the tendency is to sort of be out of sight, out of mind. But as Rich noted at the beginning, there are a lot of environmental considerations that still need to be managed. We talked about the surface water. We talked about the settling and cover conditions. Leachate and groundwater are issues at a lot of closed landfills. And, of course, as we talked about today, landfill gas. So just because it is not accepting waste doesn't mean that there aren't environmental considerations that need to be developed or maintained. One of our key recommendations in working through this project thus far is to really utilize existing resources. Lots of times we think about resources as being materials or equipment, and those certainly were resources that we were able to capitalize on through this project. We talked about the biofilter media itself and the roll-off boxes being procured by the city directly. We talked about some of the infrastructure, the condensate tank and the blower from the current system being utilized. But what we really felt was one of the strongest existing resources that we were able to utilize on this project was the people. Specifically, the regulatory agency. We worked hand in hand with them through both the design and the permitting process. They provided an example of a fairly recent biofilter project that they permitted in the state of Washington that helped us shape our proposed operations and maintenance plan and shape our landfill gas sampling plan to get this through the permitting process. As you can see on the screen here, there was also a newspaper article that was published in one of the local Spokane papers, and folks from the city solid waste staff as well as the state regulatory agency were quoted in this article, and that really helped shape this presentation this project with a positive outlook and really met one of the city's kind of overall objectives of being a good neighbor. So utilizing both physical resources as well as people as resources was something that really helped this project be successful to date. And that goes hand in hand with the last bullet that we have shown here. Lots of times in solid waste projects and other projects as well, you consider your regulators to be sort of an independent third party that you have to appease. You know, you come up with the design, you throw it over the fence, you receive comments, they throw it back. But we really gained a lot and benefited a lot of good value in working hand in hand with the regulators to help develop this project. So that's an approach that I would certainly encourage based on our experience thus far. So with that, I would like to open it up to questions. Shelby, can you help us facilitate this process? I know we had a couple of downtimes with the sound during the presentation.
Yes, actually, I see there are 2 comments. Britt made a comment. She says, you may want to look at mixing in small amount of old media with the new media when you change out units to help prevent odor issues. So that's just a comment that she had. And then we have a question from Mike, who says, is there a concern that with continuous operation, the methane might fall into the explosive range 5 to 15%? And if so, would flow be reduced to match generation, or perhaps makeup air be added to bring it below 5%?
Good question. Rich, that's not one that you and I had really talked about to date. However, based on the concentrations that are being seen currently, I don't think that would be an issue. However, we do need to monitor both more frequently up front during that 30-day initial operating period, and methane is certainly one of the parameters that we need to monitor for. And then it is also a parameter that we need to monitor for throughout. If there were to be an issue with falling into that explosive range, I think the approach that you described would probably be the most appropriate approach to maintain effective operation of the biofilter.
Right, and I guess I would add that I think that initial period of evaluation is going to be really important, both for us learning and for us showing the regulators that we are really committed to this process. So, going back to Britt's idea there, it's a very good idea. We could, we have a lot of options to look at, obviously, and when we look at items like keeping a small amount of old media in there and possibly doing a change out a little bit sooner than what we would anticipate until we get a better handle as to how that's going to play out over the first few months will really help us to shorten that learning curve in conjunction with taking those monitoring the gases through there so that we can start to get a good picture as to how that is.
Great, and then Lori has a question. She says, is this site over the NMOC threshold in NSPS, thereby requiring gas collection and control?
No, it is not. We put in the gas collection and control just as part of the closure of the site, but it did not reach the NMOC threshold.
Okay, and Bud Latta wants to know if LFG is near saturation, do you see an opportunity to minimize water addition?
That's an interesting question. I hadn't thought about that. My initial thought is that we would probably want to try to maintain the water addition in order to keep that optimal moisture content for the bacterial process to continue breaking down the methane. However, you bring up a good point. There is going to have to sort of be some experimental operating conditions happening so that we can figure out the best way to optimize the system. And as Rich noted, we may need to swap out material early just until we get a good handle on how long that saturation process will take.
Great, and then Lori has another question. What is the estimated quantity of Lachey from the biofilter?
We don't have a quantity for that that we've currently estimated. It'll partly depend on how quickly the biofilter media itself will absorb that moisture, and then any kind of breakthrough that runs through that process. The nice part is that the city has a fairly good-sized condensate tank that exists, as I noted, out at that site. So even if that breakthrough happens and we end up getting a decent amount of leachate flow through there, we still think that could be stored and collected and disposed at a minimal frequency. So we don't anticipate that there'd be a lot of labor associated with that. However, we don't have a quantity estimated at this time.
Great, and then Mike has a question. Are there moisture sensors in the media to control when and how much water should be added?
We are not planning on putting in moisture sensors for a location where we opted to go with sort of a low-tech variation of this biofilter. If you were to install this at an active landfill or a site where you could hook up sensors to an existing SCADA system or something like that, having moisture sensors would be a very positive benefit so that you could easily track the moisture content of the media. However, because this is sort of isolated isn't the right word, because we want it to be as low maintenance as possible, we're going to rely on the regular monthly monitoring of the parameters identified in that last list that included moisture. That's going to be kind of a check-in, monthly check-in process for us instead of using moisture sensors. However, again, I would certainly recommend moisture sensors in a different application.
Okay, then Bud had another question. How would this technology work in a cold climate like Canada?
That's a good question because the temperature definitely impacts the effectiveness of the biofilter itself. Um, Spokane, I would venture to say, Rich, you chime in, it gets pretty chilly in the winter. So the seasonal variation will definitely be something that we need to watch. I think there are opportunities to retrofit something like this modular unit for cold weather application, whether it's some sort of insulated box. There are some studies being done on in-ground biofilter units too. So there are options where you could look at essentially insulating the biofilter media to keep it more consistently operating.
Right. Yeah. The only thing that I would add is we do consider ourselves a cold weather climate here, which you look at the road gets well used from the spiked car tires every year because they're worried about that. So it is something that we're definitely going to have to take into consideration and make sure that when we're talking about temperature and moisture that we can keep those in some sort of optimal range year-round. And for the biggest part of the year, it won't be a problem, but during those winter months, it could be.
And just keeping in mind, too, that the time that it takes to collect the landfill gas through treatment, through discharge, is really quite fast. The residence time of the landfill gas in that biofilter itself is only required to be 15 seconds based on our theoretical calculations, our chemical calculations. So landfill gas that's coming out of the ground will be pretty warm. So we would anticipate, because it's continuous operation, that you can keep your your biofilter media pretty well temperature controlled based on the temperature of the landfill gas. However, of course, that does get impacted by the surrounding climate temperature.
Okay, and I think that's the end of our questions. I don't see any more. If you do have any other questions, you can contact our speakers. Their information is on the screen. And I just would like to formally thank Olivia Williams and Rich Hansen for doing our presentation today. It went very well. Also, for those who did lose sound in the middle of the presentation, it is being recorded. So if you need to access that recording, you can contact Jessie Maxwell at jmaxwell@swana.org. Okay, and actually I think another question is coming in. Oh, Britt says, thanks. Very interesting site. So, great. Thank you guys again, and thank you all for attending, and we hope to see you at another SWANA webinar.
Thank you very much.
Thank you.
Bye, everyone. Enjoy your day.
Thank you.